Okay, the last thing we're going to cover in chapter 1 is circles. So we're going to define circles and all of the parts of circles. There's our vocab. Okay, a circle is a set of all points in a plane at a given distance from a given point. So the purple thing there is a circle. All of those points together are a circle. And by technical definition, in geometry, you wouldn't color that in. It doesn't include the stuff inside, just those points on the outside. And then we have a point in the middle, and that is called the center. We can give that point a name, just like we can name any point. I'll call it A. And then the circle is now circle A. We name our circles by the name of the center point. Okay. And I can draw a line segment that goes from the center to the circle, and that is called the radius. So we call this line segment the radius, and the radius is also the distance, the length from the center to the circle. So a chord is a line segment that has exactly 2 points on the circle, right? The endpoints of the line segment are on the circle. So we have AB over here is a line segment with its endpoints on the circle. So it is a chord, okay? Whereas RS here goes through the circle. So this is not a chord. If I named a point, oops, there, if I named that point, let's call it A, B, C, D, F, G, H, I, J. I think I can name it K safely. If we called that K, then SK would be a chord as well. Okay, so you can have a chord be on top of something that is not a chord, but in order for it to be a chord, the endpoints need to be on the circle. A diameter is a chord because it has endpoints on the circle, but it has to pass through the center. So a diameter is the largest chord we could have. It's the longest one in any one circle. And it has endpoints on the circle, and it also passes through the center. A tangent line intersects a circle in only one place. So here we have EF, which is a tangent line, and it intersects the circle at point F. Okay, that is the only place it touches. Every other place it doesn't. Okay, that is what makes it a tangent line. In order for circles to be congruent, they have to have the same radius. So any circle that has the same radius as another, those two have to be congruent circles. Concentric circles are circles that are coplanar, so they're in the same plane, and they share the same center. So these CDs over here, or maybe they're DVDs, they are concentric. We've got the circle on the inside and the circle on the outside. And they have the same center, so they're concentric circles. Okay. So circumscribed and inscribed are relational terms, right? So this picture has a circle that is circumscribed about a triangle. Okay. So because I mentioned the circle first, I use circumscribed. If I was going to talk about the triangle first, I would say the triangle is inscribed in the circle. Okay. So they can be used either way, depends on which one you're going to start to talk about. But it's important that you know those two terms and we talk about them a lot. So circumscribed means it's on the outside, and inscribed means it's on the inside. Okay. An arc is a part of a circle. It's just a small part of one. And we can write arc AB here. So we write that either as AB and we put a little arc symbol over it, or just like a line segment, I can go in the other order. So I can do BA with the arc over it. So that's arc. It's the same arc written that way, and we put an arc over it, just like we would put a line segment or a ray or a line over it. A semicircle is an arc that goes through it's half of the circle. So um, that is a semicircle. Okay. And the one that they've actually named for you here is the one up top. And I know that that's what's named because they said semicircle APD. So when we name an arc that is smaller than 180 degrees, we use 2 points, the 2 end points. And if we're doing 180 degrees, which is what a semicircle is, or larger, then we're going to use 3 points. And use the end points and then 1 point that it goes through. So here, when they say semicircle APD, they start at A and go to D. Okay. So minor arc is going to be less than 180 degrees. That looks terrible. There we go. Minor arc is less than 180 degrees, so it's less than a semicircle, and a major arc is greater than that. So larger than a semicircle. And again, a major arc, we're going to use 3 letters to name, and we use the endpoints and then 1 point that it goes through. Okay, and I've been mentioning degrees for arcs, and arcs have 2 different kinds of things that we talk about. There's their measure, which is a degree, and there's a length, which is an actual distance, how long it would be if we stretched it out flat. How long is that? So the measure is going to be the same as the angle of its central angle. So a central angle has its vertex is at the center of the circle. So this 45-degree angle that you see, we don't name the center is not named here with a letter, but the vertex of that 45-degree angle is the center of the circle. So let's okay. That is a central angle because its vertex is at the center. It measures 45 degrees. So the measure of this arc, BC, is also 45 degrees. Okay. And the same thing is true for this major arc. Since this central angle is 315 degrees, that means this arc is also 315 degrees. So if we think about that, is it possible for 2 arcs to have the same measure but different lengths? Okay. And here we can see that that is true. So both of these arcs, this one and this one, measure 15 degrees. But the yellow one is going to be shorter than the blue one. So these two have different lengths, but the same measure. And that is the end of 1.7. So, 1.7, all about circles.